Hi, it's great to be here to be able to talk with you about how we manage security for big data with a small team. I'll cover some of the security issues that we had to deal with as part of our growth and which parts of our security program were, in my opinion, the ones we got the most value from. In some cases, these decisions were about how we developed our code or our infrastructure, but other decisions also had an impact, such as participating in a private bug bounty program. So welcome. This is the agenda, and hey, I just wanted to say I'm actually really excited to be here, and my name is Andy Leeb, and it's great to see all of you here. I'm glad that you decided to spend some time with me today. So I'm going to talk about how we manage security for our software as a service Python application. I'll start off with some introductions, and then I'll get an overview of the software. I'll describe a bit about what it does and its architecture. And then I'll move into more specific security measures that we implemented. And hopefully I'll be able to leave some time at the end for questions, but I know there's a gallery afterwards. So maybe we'll just take it up from there. As I said, I'm Andy Leeb, and I currently work as a senior solutions architect for Onna. Although I'm part of the engineering team there, I'm a bit more client facing. So I was initially hired as a solutions architect based on my background of owning a business and generally being a personable guy. Anyhow, outside of my amazing people skills, I have 20 years experience as a software engineer. I have a fairly broad background, including time as a web developer, a Python developer. I've spent a lot of time as a Plone, working with Plone and being involved with that foundation and the organization. As well, I've done some data analyst and data engineering stuff. I ran a Plone consultancy for a while, and I've worked with various US government agencies as a programmer for research projects. But most recently, I was in charge of building the security program at Onna. And this talk is mostly about that, what we did as an organization to build our security posture, and what, in my opinion, we derive the most value from. I'll talk a bit about what the Onna platform does and describe some of the security measures we undertook as a policy that, like, organizationally, that applies to the whole organization, and then measures we implemented for operations and engineering security. So yeah, I built this current security program at Onna. Fortunately, we've added to our security team, and we most recently brought on a very experienced security engineer who's in the process of revamping what's there. But with staffing up our security team, I've moved into just being a stakeholder in it instead of driving it entirely. So I get to let someone else worry about some of the stuff like auditors and attestations and certifications, but I still work really closely with the engineering teams to ensure that we're maintaining our security posture. So what exactly is Onna? At its core, it's a platform that securely collects data that's stored in the cloud, and it makes it useful, so like searchable or archived. So when new data is collected or existing data is updated, we create a representation of it and store it in cloud storage. So as you can imagine, we store and process a lot of data. Additionally, as the source files are processed, our internal indexing and object stores increase, and this is where the scaling part comes in. Our security has to scale with the size and complexity of the platform. And so all of this has to happen within a set of pretty strict security requirements. So we have to ensure that one thing doesn't step on the other, and that we can easily adhere to whatever security policy and processes we have in place that they won't interfere with innovation and with driving the features forward. We're also growing pretty quickly, and so we want to continue to innovate and incorporate these security processes into new hires and all that sort of thing. And so what exactly are these security requirements? Well, basically all data must be treated as private, and so part of that is that we have to keep it confidential as well, so only the people that are supposed to see it or have been explicitly shared or permitted to see it can see it. We have to limit access by default, but it is a collaborative platform. So that is a key part of what we do, and we have to allow that sort of interaction between people through our platform. We have sort of an overarching body of SOC 2, type 2 compliance that we have to adhere to. And as well as we move into other industries, we have to make sure that we adhere to those so we have, in order to work with the financial services, we have to be FINRA compliant, or at least partially FINRA compliant for what we want to do. The foundation of our security program was really set up by a very small team. Generally it was just one person writing policy and then working with various team members for implementation. We're very fortunate as an organization to have, experienced team leads who understand the importance of having security as a fundamental aspect of the platform. So the technical decisions and requirements already have security considerations built in. So what exactly is Onna? And so Onna is a knowledge integration platform. And what might that be? It is a new solution category that helps enterprises make full use of their proprietary knowledge through the integration of multiple workplace, cloud, or on-premise applications while ensuring that their data is protected. So at its core, like I say, it's a platform for collecting data and processing it to make it searchable through indexing or textual analysis and other document processing techniques. It's used a lot in the legal profession as well as in IT groups for compliance and InfoSec and security teams for data protection. It's recognized as the de facto tool for gathering Slack conversations. So yeah, we collect, analyze, and store proprietary data. And just to be clear, we don't monetize this in any way. And we're not in the business of being data brokers. This is private data, it's proprietary, and it stays that way. So I'd like to talk about now the use cases that the software does cover. So one of the big ones is e-discovery. And for those that aren't familiar with e-discovery, that refers to the process in which electronic data is sought, located, secured, and searched with the intent of using it as evidence in a civil or criminal legal case. So we have to make sure that the data that's collected is admissible in a court of law, in a US court of law. It's also used a lot for compliance. One of our core components of the platform is searching and indexing data. So, many of our clients use the Onna platform to enforce compliance. We've also moved into DLP, or data loss prevention. And so again, one of the core features of our platform is unattended searches that provide warnings if a particular phrase or something is encountered. So you could tell if something that you didn't want people talking about in a public forum is being talked about. One of the other big things that it does is it eliminates the silos. So it's used a lot for knowledge management. And so essentially you're able to search for everything in one place. So instead of having to go to GitHub and use their search and then look in your email or look in Slack, you can search for everything in one place. Another big use case that we have is for preservation and archiving. And so that's used in legal proceedings a lot, but it can be used anywhere you might need an archive of data, for example, in financial services for some of their compliance needs. And so you can imagine who might use it from some of these use cases. And so we have a lot of corporate legal teams in tech companies that are our customers. But we also have independent counsel and lawyers that use it for e-discovery in particular. And we're starting to notice an increase in IT personnel and IT groups within corporations using it, for compliance or data loss prevention. And as well, the same sort of thing is true with InfoSec teams that have started using our platform for some of the same ends. So now that you have some idea of what it does, or what the use cases are, I'd like to talk a little bit about how it's built and the architecture of the platform. So you can sort of see from this diagram that we have a lot of services running. It's a microservices architecture, and we use Kubernetes for our container orchestration. We've implemented it on Google Cloud Platform, but it's also completely AWS compatible. And in fact, we have some instances currently running on AWS. The platform exists in a virtual private cloud, and we leverage a lot of the tools that come with that. For example, like managed Kubernetes and various other services that are provided by our cloud provider. So in the diagram, each of the blocks is a major component in our platform, and it's roughly analogous to a node in Kubernetes. Some of the components are non-preemptible, like message brokers or persistent storages, but other parts can scale as needed. So not pictured are managed services that we leverage, such as like enterprise key management or cloud storage and even load balancing, and also, not pictured are some of the monitoring and alerting components that we have for internal uses. But as you can imagine, there are some complexity issues. But more importantly, with all these components, we have a somewhat large attack surface. The reverse proxy is a single point of ingress, so the services aren't publicly available. But our security policy has to encompass all of it and also scale with the platform. So, what does all this mean? And, essentially we get some things for free, I mean, obviously we're paying for it, but, because we leverage Google Cloud Platform, they maintain, a firewall that ensures that the managed Kubernetes is working correctly and that, individual accounts are kept private, which isn't to say that we don't have some configuration that we have to do, because Kubernetes, works essentially by, IP tables configuration. But, we also leverage the storage that's provided. And so that's encrypted by default. And so we don't have to build that, so that happens transparently for all things that, come into our platform. And so, as part of that, we also leverage the managed encryption key service that's provided. And again, it's tooling that we don't have to write, but that, is already integrated into the platform. Another big thing that we get, so for free is IAM, which is Identity Access Management. And so with that, we can control, who has access to, our backend. We can also audit, events that happened or people that have done things. And we use it, of course, to manage user permissions. And as you look at the diagram across the bottom, there's also the integration agents. And those are a pretty key part of our platform as well, because they actually gather the data that gets stored and processed on our platform. And so what do these integration agents do? Well, they collect data from various sources via API calls. And so they collect pretty much anything that can be stored electronically in the cloud. And as you can imagine, it's a lot of private and proprietary data. And we don't really know what that data is when it's being collected. So it could be HIPAA data, it could be PII of any sort. I mean, it could be social security numbers. It's like whatever they have decided to upload into that particular cloud service is what we're gathering. And so because we don't really have any knowledge of what it is that they're gathering, our security has to apply to all things pretty much equally. So all the data has to be treated as confidential. And so, and then, and an aspect of that is that all data has to be encrypted, both in transit and at rest at the disk level. And so every time we collect data from an API call, we create files which are stored securely on our platform in the cloud storage. So for example, for each Slack conversation we collect, we would create a file which is used as a way for us to access and index it, but that file is also encrypted when it's stored on our platform. All the data is secured, securely transmitted, via TLS, and then again encrypted when the file itself is stored. So we leverage a lot of the built-in security of Google Cloud Platform or AWS, as the case may be. So all this sort of happens transparently for everything that we collect and store. We use consistent encryption standards, AES 256 across our storage, and accept a minimum of 1.2 TLS for data in transit. So how do we ensure the data privacy? Well, in order to collect it, you have to have access to it already. Like we can't, magically collect things that you shouldn't be able to see. So, whenever possible, we use OAuth for authentication and authorization. And so the OAuth process provides a token for us, which we store to enable long-running processes to collect data unattended. We only ever ask for read permissions when we're doing the authorization part. So the endpoints that we're getting data from are read-only. And, we don't actually have permission to write back data to these cloud services. We then, of course, store the access token in our persistent storage. And these are stored in a protected field so that not even the owner of the data source is able to read that token from the API. The auth process for starting collection ensures that you will only ever be able to collect data that you should be able to. So for larger organizations, a service account or an admin level is usually required for these sort of big organization-wide collections. For non-OAuth sources, we still enforce the same access rules and privacy policy, but authentication can be provided in other ways, such as a password. But again, the same security policy applies. So other things that we do in order to ensure data privacy is, like I've said before, the encrypted storage. We also do things like we separate out storage per client. And in fact, users within that client's instance have separate buckets as well. We also separate out search indexes as well as persistent storage. And these are all separated out per client. And no data is really ever intermingled with other data. So we collect from a variety of sources, like I say, anything in the cloud. And, but because our application collects data from, GSuite and Gmail and G Drive on behalf of someone else, our application also has undergone a pretty serious security review from Google itself, which is, kind of ironic because we're already using their platforms, pretty substantially. But, it was a pretty rigorous process that was ultimately caused by a change in how Google itself handled its own API security. So this meant in order to continue to collect data from these sources, we had to recertify our application with them. But anyway, so now that we have an idea of what the platform does, and now we can talk about what was done to make it secure. And the way that I approach this is to break it into two main categories: organizational security, which sort of applies to the company as a whole, and application security. So organizational security includes things like endpoint protection on user laptops and, applying the principle of least privilege for the roles that people have. And so you're not really able to access things that you shouldn't, access as part of your job description. We also handle things like audits, in particular like ISO 27001 and SOC 2 Type 2. We've started working with financial services firms, so we do some FINRA stuff, which is the regulatory stuff for financial services. One of the other things that we did is, since we are, at heart a software company, is that we have a pretty substantial VPN infrastructure that allows access to particular environments. And not everyone has access to the same environments, and we'll talk more about that later. But moving into application security, this includes things like secure coding practices and peer review for all pull requests for code that gets into a production branch. We have a lot of automation happening. We have a CI pipeline, and that's where we do a lot of this automated stuff. And so we might have like static code analysis with Bandit. We have built-in CSRF protection. We built a CSP, a content security policy. We also participated in a private bug bounty program, which I'll speak about a little bit more. Additionally, we have IDS, IPS set up in front of our production environments. And for our operations team, one of the big things that we did was we built out the configuration as code. So not only is our setup for infrastructure standardized, but it also goes through our secure coding lifecycle and goes through peer review. So a little bit more about our organizational security practices. And so these are really used to build trust in our service. And they're very public facing, and clients all ask for these as part of their due diligence when they're thinking about using our platform. So the SOC 2 and the ISO are both annual audits that are done by a third party, where they really dig into our security processes and policies. There's a bit of overlap between the two, but SOC 2 is a little bit more security oriented, whereas the ISO is more about business practices, like you say what you do and you do what you say. So it doesn't just include engineering practices. Both of these audits also include things like HR. So we inspect how we manage our employees, and like what training they get, or, how they're onboarded and how we vet them, or, and even how access is granted, as well as, what we do when employees are offboarded, like how we ensure that they don't have access to stuff that they shouldn't have after they leave the company. So the SOC 2 really goes a little bit deeper into our security policy. And so, for example, we have to provide evidence to show that our logging system has protection from tampering and that it's secure, and that we have a way of handling change management, both for application changes as well as for infrastructure. Other topics might include network monitoring. And even though we're a largely distributed team, we do have regional offices, and we want to make sure that, there's nothing, that shouldn't be there on our network. And as well, we cover, how we monitor our application and even our vendors. And so, the audit does guide some of our security policy, but it doesn't dictate it. And again, neither is the compliance the sole source of our security. We aren't just, interested in the checkboxes. We want to make sure that we have a holistic view of our security. So one thing, again, that we did that really provides a level of security, internally, is that we have separate VPNs for separate environments. And so all the environments are only ever accessible through our VPN. And so development and staging and production and QA even all have different environments and require different credentials and logging into a different VPN in order to access them. And so this actually ensures a couple of things. And one, of course, is that it makes sure that only those who are supposed to have access to that environment have access to it, because you have to request access to any particular environment. But it also minimizes, sort of inadvertent mistakes, so that there are less people able to manipulate some environment, then that there's less chance that something will go wrong with, something that someone did. In our development environments, pretty much all engineers have access to that. But for QA, only the QA team has access to that particular one. And so again, like I say, very few people have access to our production environment, which has all of our client data in it. So, kind of along with that, we also assign permissions and access based on your role. And so it's not just the role, like with respect to how it's referred to in software engineering, but it's also like the job that you do within our organization. So as I said before, really only a handful of employees have access to our production environment. The operations team, of course, does to keep everything running smoothly. And, our support team does, of course, some of our engineering team, our devs, have access to it as well. But, the support team has access to it, but only in the event that they actually need it. And so they request access to it in case they need to troubleshoot something for a client. And then when they're done troubleshooting it and the issue's resolved, they don't have access to this anymore. But, like I say before, the engineering team does have access to the development clusters. And so everyone's pretty much assigned, credentials for that VPN. So moving into the application security, we try to practice secure coding practices that are, we've sort of adopted a culture of this. And so we try to make sure that everyone understands that these are things that we take very seriously, of course, but that they're also easy to do, that, by default, these are things that are done. And so we have all this stuff written out in a policy, and a lot of it's pretty standard operating procedure that, most people who have worked in this sort of environment, understand and know that that's something that they're going to, be involved with. And so, all of our code is always peer reviewed before it gets put into a production branch. Some of the other things we do that include in our secure coding practices is that any input that comes in from a user is validated in both the front end application and in the back end. So we also don't allow particular things in that, submitted data. For example, we wouldn't allow internal URLs so that you couldn't try to escalate privileges and pull data out of the platform. We're very much an API driven product, and all of our API endpoints must have permission, attached to it. And so since we use Guillotina as our REST API server, it already has a pretty robust set of securities and permissions in it. And we, leverage that by building on top of it. Some of the other things that we do that maybe aren't as obvious is that we actually enforce documentation in our CI pipeline. And so when a new feature is developed and someone's looking to merge into the production branch, we ensure that there actually is some level of documentation there. So some of the other stuff that we try to do is we generally don't allow developers to write SQL queries in order to get data. Like, we build a library in the back end that does that for us. And so we query another API that has our data in it. And that sort of eliminates a lot of the sort of SQL injection attacks that you might, that are, you've probably heard of and, are pretty heinous. But we also do things that are somewhat invisible too. So for example, like schemas that we have for data, they're enforced. And so if there's a missing field or something like that, the product will, alert us and let us know. We also have policies protecting against checking in passwords into our repositories. And so we use encrypted secrets instead for these things, and our container orchestration and deployment process handles a lot of that stuff for us. Something else that we've done that I like to touch on is that we enforce MyPy as part of our CI pipeline, and this is done automatically. And so it did take a little bit of effort to do it, but that's eliminates a lot of the sort of guesswork that you might have in making sure that we have essentially type safety in Python. Some of the other stuff that we do to ensure some of these secure coding practices is that the images that we build, the Docker images that we build, don't run as root, so that way you can't escalate privileges if you manage to get in there. And, we also tend to build these microservices to do a single thing. And we also make them generally try to do a single process per pod so that you eliminate some of the buffer overrun or memory overrun issues that you might run into that would allow you to escalate into a different pod. We do a lot of automated testing as well, as you can imagine. And it's not just unit tests that we run, even though that's a big part of it. We also have, for example, Bandit configured so that it doesn't, scan for things that we don't use, like we're not a Django shop, so it doesn't look for those types of vulnerabilities, but it does, we do have it configured to, check and do that sort of static analysis. We also, of course, have, unit tests that get run on each push to a branch, and, we have Jenkins running, all of these tests for us so that we do have feedback, a feedback loop that allows us to see, some of these tests, and if there's any issues with it. But we also run integration testing with Robot Framework, and that's also automated, and, again, and it's run with each push. And so all of these things, working together, have a baseline of security that, we can, be relatively sure that the code that's going into production is fairly secure. Our operations team also does automated scanning for weak SSL ciphers so that, we don't have any sort of, issues with those sort of CVEs. Another sort of big thing that we do is that we have a IDS IPS in front of our production environment. And this is really, it was a checkbox on the SOC 2, but it's really just good practice anyway to have it. And so the tool that we have also handles Docker image vulnerability scanning for us, which is also tied into our CI pipeline. And so as an image is built, it's scanned for vulnerabilities. And if the base OS or any of the libraries, are flagged as out of date or, have a security issue with them, then we can, remediate it before it actually gets out into production. This ties a little bit into our vulnerability management policy, but, at the application level, finding a really good IDS, IPS that integrated with our VPC, that integrated with our cloud provider, that integrates with our, with Kubernetes, was really not the easiest thing to find. And, a lot of these tools are really focused on AWS, and GCP support is a little bit lagging. And so we had to really, find the one that really suited our situation the best. We also needed to consider a couple other things, and, specifically like where the actual monitoring is taking place and how that's actually accomplished. For the tooling that we landed on, the agents are actually deployed per pod as a kernel extension. And so they can just be built as part of the base image. We don't have, any additional steps in order to ensure that these things are monitored by, this tooling. So we also make sure that notifications are done via a dedicated Slack channel. So this tool also provides a number of really useful views into our infrastructure. Because it understands Kubernetes really well, we're able to see some interesting graphical representations of what a deployment might look like, or what our environment or a particular cluster, looks like, which is, pretty helpful for when we're trying to find security issues or, just monitoring things. One of the other things that's really nice is that it keeps a full history of every process that's run on a pod. So in the event of a breach, which we haven't had, we can go back in time to trace exactly what happened. And so we've instrumented it to notify and alert us when a command is run that we may have expressly forbidden. But, this was a little tricky because in a microservices environment, we have a lot of inter-service chatter, a lot of requests are being made. And so we don't want a lot of false positives, when a request is made between two, services. But this is really a very valuable tool for us. And while it does, have a price tag attached to it, and it is per node, but, we can control a lot of the costs of it by engineering acumen. It also integrates, really nicely with our existing monitoring and alerting infrastructure. And we use Prometheus Alert Manager and Grafana for a lot of our monitoring. So, it's not really just that it was a checkbox. We derive a lot of value from it, but it's also that, every single one of our client requirements that came in includes having an IDS or an IPS. And so this really sends a very strong signal that we have a real commitment to keeping our platform secure, and that, our clients can rest knowing that we're doing everything we can to keep that security posture in place. And so one of the other things that we derived a lot of value from was a bug bounty program. And this is a private bug bounty program that we're involved with. And, if you have the budget for it, I say it's totally worth it. We have actually, gotten a lot of value from it, like I say. And so we work with the managed private bug bounty program. And so what that means is that the vendors vet the security researchers and invite them into our program. And then when a vulnerability or an issue is found, they do the initial triage on the reported issues and ensure that it's reproducible, and work with the security researcher to understand, if it's a critical or a high or a medium, and, what the severity of it is. And so, we're privy to all this communication, and we're alerted, through their platform, what's going on with that particular issue. And so essentially what happens is that the security researcher has a way to either has an account or can make a free account on our service and on our platform, and then they can start testing. And we just ask that they make it obvious so that we know that they're a security researcher. And there's some guidelines, like we don't want them DDoSing our site or anything like that. And those sorts of things are, will get them kicked out really quickly. So, but essentially once we have that vulnerability report, we have a dedicated small team internally that handles the triage and resolution and assessment of it. And so when we first opened it up, I mean, there were, the initial findings were, I don't know, I lost some sleep over some of them. It was, a little bit, I don't know if surprising is the right word, but some of the stuff that was found were corner cases that was data that we definitely didn't want leaked out. And so we were able to remediate it really quickly. But, a lot of it came very quickly when we first opened it up, because, the system sort of gamified in the sense that they're leaderboards, but the highest value things are critical and high. And so that's the first things that the security researchers are really looking for, which is, good for us, because that means that, some things that, could be very serious problems are, dealt with very early on, essentially. But, like I say, when we first opened it up, we received a lot of well, not a lot of reports, but we received enough reports that it interrupted our development cycle. And, fortunately, since then, it's improved our security of our product quite a bit. And we have a lot less sort of hair on fire sort of situations where we needed to drop everything and fix something, remediate it right away. And it's sort of become a little bit more quiet. And it may be that, due to sort of the external circumstances of a global pandemic, that there's just a little bit less, people involved with it. But, we still receive bug reports, and we still, use it as a way to improve the security of our platform. So, like I say, the value that we get from it isn't just that we can remediate these things. It improves the security overall of our platform. And so the security researchers are really focused on, just that, on researching the security. And so they'll really dig into some of these corner cases or some of the access things that may not be covered by our, like our testing, or, as we develop features, even though we have security as part of, internalized and part of our practice, some things, you don't have the ability, because we don't have a red team essentially to really attack our software. And so they really provide a really great service for that. You know, we do have to make sure that we keep tabs on everything that's going on with the bug bounty program, of course. And, you know, we want to make sure that we maintain a good relationship with all the security researchers that come in. And so we want to work with them. You know, we don't treat them as antagonists, of course. And we, you know, when we ask for clarification, we want to make sure that we understand what they're driving at, and that, you know, whether or not we consider it, you know, to be at the same severity that they might. So, you know, a lot of the things that initially came in were resolved, like I say, but the things that are trickling in now have more to do with, you know, access and sharing, as opposed to any sort of environment issues or, you know, some, you know, other things along that line. But, you know, we have to, you know, be fairly circumspect with, you know, what we get from them. And we have to make sure that, you know, we're, you know, that the assessment, the risk assessment is, you know, conforms with what we think it is. And so anyway, it's been an extremely valuable experience, and we're going to continue doing it. And like I say, it's something that if you have the budget for it, I would highly recommend, you know, working with a bug bounty program. You know, realize that it does take some sort of manpower. And, you know, like I said before, like some of the things that come in will stop a development cycle and must be addressed immediately. But, you know, eventually it does slow down, and it gets to the point where you can integrate a lot of these things into your development cycle, you know, particularly as, you know, as you work towards having a stronger security posture. So, yeah, I mean, the takeaways that I hope that I gave on this is that, you know, organizational security and application security, you know, have to sort of coexist with both. And that while we derive a lot of value from particular things within the application security realm, you know, with having secure coding practices and having an IDS, IPS, having a private bug bounty program, you know, that without the organizational security, without the people being, you know, aware and conforming to these security policies, you know, you got to have both. So thank you for joining me today, and I will be available for questions in the gallery afterwards.
Awesome. Thank you so much, Andy. That was actually a pretty good time too. So we've got a few minutes for questions. I am not seeing any in the Slack. Cameron wanted to know, how big is your dev team?
Our current dev team is, let's see, it's more than 20 at this point. We've been experienced kind of a explosive growth. So and our team is pretty distributed. So we have actually a bunch of people, particularly since we've all been, you know, working from home, that I haven't even met so far, you know. But to back up just a little bit, like when I started, you know, in my current position, we had a dev team of a dozen people, maybe a little less. So it was, you know, a little bit different at that point. And when we were developing a lot of these security things, it was much easier to, you know, sort of communicate across, you know, that overhead was much lower than having, you know, 20 or 30 people or maybe even more.
Absolutely. Perfect. Well, we've got a few minutes actually about 20 minutes before the next talk starts. So I will put the gallery link in track 2. Andy, if you've got a few minutes to hop over there, and I'm sure folks will have some more questions. So I will stop this stream and toss that in track 2, and we will see you over there.
Great. Thank you.